Hello folks, Mrs. Findlay here. Today we're going to start looking at fractions. So this is a topic that will take us over quite a few lessons, and you can see here that we've got lots of learning outcomes for the topic. So the ones that are in the kind of pinky red colour are ones that I want all of you to be able to do. The ones that are in green, most of you should be able to do. And the ones that are in this dark orange colour, some of you will be able to do. Okay, so we'll just take it nice and easy, and we'll hopefully get to the stage where everybody understands as much as they possibly can about fractions. Okay, so the first thing we need to look at is the meaning of a fraction. So what I would like you to do just now is pause the video and either discuss if you're in class or have a think if you're not. I want you to think about what is a fraction, what do the different parts of a fraction mean, and why are fractions useful or important. So have a discussion about that just now, pause the video and then come back. Okay, so I hope you've had a useful discussion there or a useful think. So what is a fraction? You've probably come up with quite a few different words and phrases to describe what a fraction is. A fraction is a way of splitting. Okay, a fraction tells us that we don't have complete whole ones. Okay, if you think about a pizza that's been cut up and somebody's taken some of it, then they have taken a fraction of the pizza. Okay, if we're talking about the amount of people in the UK who've had their COVID vaccination, we could talk about what fraction of the population have had that vaccination. So a fraction is a way of explaining how much we've got if we don't have the whole thing. Okay? So the different parts of a fraction, let's look at what they're called first of all. The top of a fraction is called the numerator, and the bottom of the fraction is called the denominator. Now, through these lessons, I'll tend to use the words top and bottom more often than I'll use numerator and denominator. You do need to know what these words mean, but I don't want you having to stop and think about which they are every time I use them. So it's more important to me that you understand about fractions. Okay? So the different parts of a fraction are numerator and denominator, and the denominator is what makes it a fraction. The denominator is to do with sharing. Okay? It's how many pieces your whole one has been split into. And when we're talking about splitting or sharing, that means we're dividing in maths, doesn't it? So we'll have a look in a minute at some diagrams with fractions, and then it'll all become a little bit clearer. But this is the thing that I really want you to understand, and understand this well, that the denominator is the bit that makes it a fraction. It makes it to do with sharing and dividing. Okay, so whenever we're talking about dividing with fractions, we're going to be thinking about the bottom of the fraction, the number on the bottom, which is called the denominator. Okay, now why are fractions useful or important? Well, we've talked about a couple of different ways that we use fractions. Lots of people use fractions without even realising it. Like, for example, if you were sharing a cake out and you said, how much of this do you want? Somebody might say, oh, about a quarter is fine. Or they might say, just a tiny bit. Or they might say, split it into 4 and I'll have one of those. Okay, so we use fractions in our everyday speech without necessarily realising that we're doing it. But we're going to have a little look now at what fractions might look like and how to understand what fractions mean. So to do that, we're going to look at shading fractions. Now, I've got lots of blank shapes here, and we're going to look at just some of them, and then I'm going to get you to do some yourselves. So in the first circle, I didn't want to shade them to start with because I want us to think about the denominator of a fraction. Remember, the bottom number on a fraction tells you what you're sharing, how many you're sharing between. okay, or how many you're splitting into. So if we look at our first circle here, we can see that we've got 1, 2, 3, 4 pieces. And those pieces are all equal. It is very important when we're talking about fractions that the fractions are of equal size. Okay, so in the first fraction there, we know we're looking at quarters. So we can put a 4 on the bottom of the fraction because that circle has been split into 4 pieces. And the number on the top of the fraction is how many of those pieces are shaded. So if I only shade one of those pieces, then that means 1 out of 4 pieces are shaded, and we say that fraction is a quarter. In America, they call it a fourth. We tend to call it a quarter in the UK. Okay, now looking at the next one here, we can see we've got 2 equal parts here. So that must mean that we're going to put a 2 on the bottom of the fraction. And if I shade one of them, then that means we need a 1 on the top. So we can say there that I've shaded 1 out of 2 pieces of this shape. Actually, it's a square. If we put it on its side or tip your head on the side, you can see that. Okay, we've got the same shape next here. And we can see that this time it's been split into 4 equal pieces. So what we're going to do is put a 4 in the denominator of our fraction before we go any further. And this time, I'm going to shade 1, 2, 3 of those equal pieces, okay? So we can put a 3 on the top, so we can say that 3/4 of this shape is shaded, so 3 out of 4 equal parts are shaded. Okay, so have a look at the next one. Can you work out what fraction of that shape is shaded? Look at how many it's split into altogether. Count the pieces. That's the number that goes on the bottom, and then the number that are shaded goes on the top. So what we can see is that we've got 4 equal pieces and one of them is shaded. Okay? All right, so what we're looking at here is kind of working both ways. We're looking at how to write down the fraction that's shaded, and we're looking at how to shade the fraction that we're given. Okay, so I want you to have a think about how we would shade 3/4 of this shape. So we would need to check, first of all, that our shape has been split into 4 equal pieces, and it has. And then we'll need to shade 3 of them. So it doesn't matter which 3. But there's 3/4 represented on that shape. Now, if I asked you to shade 3/4 of this next shape, then we've got choices, haven't we? Because we need to split this into 4 equal pieces. So our options are, we could split like this, or we could split like this, or, we could split, I keep doing that, sorry. Or we could split like, just a minute, need to put that back away, there we go, sorry. Or we could split even this way to make it into 4 equal pieces. Or we could split across the way. So we've got lots of different ways, they're not the only ways, but we've got lots of different ways of splitting that shape into 4 pieces, 4 equal pieces, and then we just need to shade 3 of them. Okay, so for the next few shapes, again, pause the video. I'm going to shade, I'm going to stop just now, I'm going to shade some of the shapes, and I'm going to put fractions beside the others, and I want you to pause the video and work it out. So don't pause it just yet. Okay, so if you pause the video now, and you can see that for the remaining shapes, I've either shaded part of it or I've written a fraction at the side. So can you work out how you would shade or what fraction is shaded? Okay, so if you pause it just now and do that, and then when you come back, I'll show you the answers. Okay, I'm back now, so I'm going to show you the answers. Here are the answers. So we can see that for this shape, as long as we've got one part shaded, doesn't matter which one. For this one, the answer is 3/8. For this shape, we need 5 of these triangles to be coloured in, it doesn't matter which 5. For the circle, we needed to colour in 7 of the 8 sections there, and for the last one, the fraction represented is 1/4. The next part we're going to go on to is finding a fraction of an amount. So, for example, we're going to look at finding a half of £20. So, actually, without knowing very much about fractions, most of you could probably just tell me straight away what a half of £20 is, and you might feel like you've not even really done any maths. But we need to look carefully at what that question means, a half of £20. So, if we imagine our £20 as piles, as piles of pound coins, then if we drew our £20 coins there, if we found a half of them, what we're doing is we're splitting the pile into 2 pieces, remember, 2 equal pieces. So if you've got £20 coins and you split that pile of £20 coins into 2 equal pieces, 2 equal piles, what we're doing is we're dividing 20 by 2 because we're sharing into 2 piles. So the first thing that we would be doing is 20 divided by 2. Okay? That would give us a half of £20 because we've got a 1 on the top. So we only need one of those halves. We need one of those piles of coins. So 20 divided by 2, remember that means how many 2s are in 20, and we can work that out if we don't already know it, and it's going to be £10, isn't it? Because it was £20 divided by 2. Okay, let's look at the next one. 1/5 of 30 kilos. So if we've got a pile of sand that weighs 30 kilos and we want 1/5 of it, say we've sold 1/5 of it to somebody, then we're going to have to split it into 5 equal pieces. All right, remember the number on the bottom of the fraction in the denominator tells us how many equal parts to split it into. Okay, so what we're going to have to do is 30 divided by 5. So if you go up your 5 times table, you find out that that's 6. Okay, so it's not just 6, is it? Because we started off with 30 kilograms. So we need our units on our answer. So it's got to be 5 kilograms. Now, the reason we didn't have to do anything else than dividing by 5 is because once we've split it into 5 equal pieces, we know what each one of those equal pieces is worth. Oops, spot the deliberate mistake there. 30 divided by 5 is, of course, not 5. I do have a bit of a problem sometimes talking and writing at the same time, as those people in my classes will know. So 30 divided by 5 is 6 kilograms. So well done, those of you that spotted that. Okay, so the next one, 1/10 of 80 centimetres. So we take a ribbon or a stick or whatever it is that's 80 centimetres, and if we're finding 1/10 of it, we need to split it into 10 equal pieces. So we need to divide 80 by 10. Okay, so that's what we're going to do next. 80 divided by 10, and that will tell us the value of 1/10 of 80 centimetres. So 80 divided by 10 is 8, isn't it? So it's 8 centimetres. And we only need 1/10, so we don't need to do anything with that. The next one to do, 1/4 of 200 millilitres. So, like before, we take our amount and we split it into 4 equal parts because we've got 1/4 here. We've got a 4 on the bottom of the fraction, so we know that's what we divide by. Okay, so we can divide by 4 now. We can either half it and half it again, or we could do a little bus stop sum if we wanted to. A lot of you will just know what 200 divided by 4 is. Whichever way you do it, you get 50, and we need to make sure that our amounts keep the correct units. Okay. What I'd like to do next is for you to practice some. So, I want you to pause the video and answer these questions. And there's a question at the bottom there as well. What do all these questions have in common? So pause the video, answer the questions, and come back to me. Okay, if you're back now, we will have a look at the answers. There you go, there's all the answers. So take a moment, pause the video again if you need to check your answers. And what do all these questions have in common? Well, I hope you spotted that all of these questions have got a 1 on the top of the fraction. Okay, a fraction with a 1 on the top is called a unit fraction. So they are all unit fractions. That means they've got a 1 on the top. Okay. However, fractions don't always have a 1 on the top. So for example, I'm going to do these ones. Finding non-unitary fractions of amounts. So that just means they don't have a 1 on the top. Non-unitary means there's not a 1 on the top. So this time, when we find 2/3 of 15 pence, when we start on answering that kind of a question, we need to be very aware of what it is that we mean. So let's go back to our pictures. Okay, so just the rough drawing there of thirds, because we've got 3 on the bottom of the fraction, so our amount needs to be split into 3 equal parts. And then to get 2/3, remember 2 of those 3 pieces would be selected. Okay, so what we need to do here is 15 split into 3 equal parts, and then we need to choose 2 of them. So we're going to do 15 divided by 3, that'll give us 1/3, and then we're going to times by 2 to make it 2/3. Okay, so 15 divided by 3 is 5, and 5 times 2 is 10. So the answer is 10p. Looking at the next one, we've got 3/4 of 20 cats. So we would need to take our room full of cats, or wherever these cats are, and we would have to find 1/4 of 20, because we've got a 4 on the bottom of the fraction here, so that means we need to share into 4 equal parts to get 1/4. So 20 divided by 4 will give us 1/4. Then, it's not just 1/4 that we need though, is it? It's 3/4. So we need to then, whoops daisy, we need to then multiply that by 3. So 20 divided by 4 gives us 5, times 3 is 15. So 15, and remember the question was about cats, so the answer is also about cats. Okay, the next one, 5/6 of 12 chairs. So we need to split our 12 into 6 equal pieces, because we've got 6 in the denominator here. So 12 divided by 6 will give us 1/6, but then we need 5 of those, so we're going to have to multiply by 5. So 12 divided by 6 is 2, times 5 is 10. And this is 10 chairs. Whoops. This time. Okay, not 10 hairs, let me fix that. That's better. All right, and the last one of these that we're going to look at, 4/7 of 21 houses. So we need to find out what 1/7 of 21 houses is. So we're going to go 21 divided by 7. That'll give us 1/7, but we don't want 1/7, do we? We want 4/7. So 21 divided by 7, how many 7s are in 21? Well, count up your 7 times table if you don't know it. Gives you 3, times 4 is 12, and the answer is houses. So for example, it might be a street that's got 21 houses, and maybe 4/7 of those 21 houses have got a white front door. Okay, so that would mean that 12 houses on that street had a white front door. Okay, anyway, over to you again now. I want you to pause the video and answer these questions. So if you answer those and then start playing the video again, that'd be grand. Are you ready? We're about to reveal the answers now. So here we go, there's the answers. Just check through those, make sure you got them all right. If there's any that were wrong, you can pause the video, you can go back, you can have a little look at how I worked it out a few minutes ago. Our next job to do with fractions is looking at equivalent fractions. So what I'd like you to do is have a look at these sets of fractions. What I've done is I've told you that 3/4 is exactly the same size as 6/8. 3/4 is the same size as 9/12. 3/4 is the same size as 15/20. So I'll just circle all these, but all of these fractions are equal to 3/4. They're exactly the same size. So if you had a pizza that was split into 4 pieces and you chose 3 of them, you would have exactly the same amount of pizza as if you'd split it into 8 pieces and chosen 6 of them. That's what equivalent fractions are. They look different, but they are exactly the same size. So I want you just to take a couple of minutes and have a look at all these fractions that are the same size as 3/4, that are equivalent to 3/4, and I want you to think, how can we spot equivalent fractions? How do you create equivalent fractions? How could we fill in missing numbers in equivalent fractions? For example, if that 6 wasn't there, or if that 24 wasn't there, how could we fill in these numbers? So I want you to take a couple of minutes just now, have a little chat or a think, and see if you can work out how we can tell that this is equivalent to this, and how you could create that fraction from this one. Okay, any ideas? Well, some of you might have spotted, for example, let me just see if I can get rid of that ring. Oops, no, can't. Oh dear, I'll put the 6/8 back. Okay, so if we're looking at 3/4 and the equivalent fraction 6/8, then it's to do with multiplying, okay? If you split your pizza into twice as many pieces, then you need to choose twice as many of those pieces to get the same amount, okay? It's the same idea with all the other fractions. So if we look at 3/4 equals 9/12, well, if you split your pizza into 3 times as many pieces, you've got to choose 3 times as many pieces to get the same amount. So the way that we create equivalent fractions is by multiplying both the top and the bottom of a fraction by the same amount. It has to be by the same amount, or the fractions will not be equivalent. They won't be the same size anymore. So if we wanted to randomly just create a fraction that is the same size as 3/4, all we need to do is pick a number to multiply the top and bottom by. And let's see, what number has not been used? Right, let's multiply the top and bottom of this fraction by 4. Okay, so 3 times 4 is 12, and 4 times 4 is 16. So 3/4 is exactly the same size as 12/16. So if you want to create an equivalent fraction, the answer to that is multiply top and bottom by the same amount. And we know that the top is the numerator and the bottom is the denominator. So that's how we check whether fractions are equivalent as well. So for example, if I asked you, is 3/4 equivalent to 18 over 25, then let's have a think. So if they are equivalent, then the top and bottom have been multiplied by the same amount, haven't they? So 3 times what is 18? Well, if we think about that, or look at our times table squares, 3 times 6 is 18. So let's have a look. Is 4 times 6 25? Well, it's not, is it? Because 4 times 6 is 24. So this fraction is not equivalent. And to fill in missing numbers in equivalent fractions, so for example, let's choose a different fraction this time, 4/5 equals something over 30. To fill in this top number here, we need to multiply the top by the same amount that the bottom's been multiplied by. So we need to work out 5 times what is 30. So if we work our way up our 5 times table, we realise that 5 times 6 is 30. So on the top, we've got to do 4 times 6. So 4 times 6 is 24. So that's how we can fill in missing numbers in equivalent fractions. Okay, so next job. I would like you to match up the equivalent fractions. Okay, so pause the video again, see if you can work these out. So a black one is equivalent to an orange one. So they go in pairs of one black one and one orange one. So see if you can work out which of those fractions are equivalent and match them up. I'll tell you the answers in a minute. Okay, are we ready to see which ones are equivalent? There are the answers. So if you want to just pause the video again and check your answers, that would be a good idea. And if there's any you're not sure about, you could ask one of the adults, or you could help each other out, or you could see if you want to watch a bit of the video again. Okay? And now we're going on to finding the missing numbers in equivalent fractions. So that's what we were just looking at a moment ago. So what we need to do, I'll do the first one with you. We look to see what the bottom, I'll do that in different colour and then we can see it a bit better. We look to see the bit that's been filled in. So the bottom of this fraction's been filled in, so we work out what has been multiplied by. So 10 times what is 20? So 10 times 2 is 20, isn't it? So we need to do the same to the top. It's all about doing the same to the top and the bottom. So 9 times 2 is 18. So 9/10 of a pizza is exactly the same amount of pizza as 18/20. Okay, and I'll get you started on the next one, then you can finish it off and finish the others off. So 3/4 equals 18 over something. So what have we multiplied by? Work out what you've multiplied by. And then when you've worked that out, you need to do the 4 times that amount as well. Okay, so same process for each fraction. You look to see what's been multiplied by, and then you do the same to the other bit. So it's either the top or the bottom you'll be given. Oops, missed a line off that one. Okay, so take a couple of minutes there to fill these in. And again, if you're not sure, ask somebody or rewind the video. So I'll put the answers in for you just now. So there are your answers in green there. Oops, there's one more that I've forgotten to fill in. Look, just noticed that. So 3 times 6 is 18. So 4 times 6 is 24. There we go. So the last thing we need to do today is just look again at our learning objectives for this lesson, and we'll see how far we got with them. So our learning outcomes or our learning objectives are here. We'll have a look and see how many we've got through today. So first of all, I understand the meaning of a fraction, and then I can represent and identify shaded fractions. Well, you did that right at the beginning, so I'm going to go tick, tick. Then we looked at finding a fraction of an amount, and remember, you divide by the bottom, by the denominator of the fraction, and then multiply by the top. So I'm going to go tick. And then we went as far as I can identify and find equivalent fractions. So we did that as the last thing, and that's where we've got up to. Okay, so we haven't done any of the rest of it, and we'll leave that for next lesson. So well done, good job. See you soon.